Hi, this is Jenny McFadden, and I'm going to report on my final project for CSCIE 63, Big Data Analytics. This is a big data case study in healthcare. The current healthcare economic climate in the United States is a confusing mess. There are people with private health insurance, some with no health insurance, and some on Medicare. Medicare is paid for by the American taxpayers. 1.45% of employee income tax goes to Medicare, and employers contribute another 1.45%. American citizens who have worked and paid into the system and younger people with disabilities are eligible to take advantage of Medicare, which provides national health insurance. Doctors who choose to participate in Medicare agree to receive the Medicare payment for their services instead of their typical bill rate for Medicare patients. There is a difference in pricing, therefore, based on if you have Medicare, some other private health insurance, or no insurance. We call these people self-insured. There has also not been much transparency for researching the fees of various procedures at hospitals, and they vary widely. The U.S. government recently released a large data set of Medicare provider utilization and payment data on April 9, 2014. This data set is available in tab-delimited format on the CMS website. The data set includes over 9 million records totaling 1.7 gigabytes of Medicare records from 2012 on how much specific providers charge for certain procedures, where these providers are located, and whether they participate in Medicare. The Obama administration has released these records in an effort to provide transparency in Medicare costs, and also with the hopes that it can crowdsource the sifting of the data to provide valuable information from it. I thought it might be interesting to see if Medicare use varied by U.S. state. I figured there were probably some states who took advantage of Medicare more and would have a higher average Medicare payment amount. It also seems only fair to account for population size, so I normalized this data by dividing it by population so we can compare apples to apples. In this project, I use Hadoop streaming plus MapReduce with some R scripts to calculate the total amount of Medicare payments made per state. I then used Excel to generate the average Medicare payments made per state, and then at the end provided a visualization of the data using Google's GeoChart API to create a heat map of the United States displaying the rates of use. In order to run a Hadoop streaming job using R scripts, there are some things to set up first. You don't have to have exactly this environment, but this is what I did. I installed CentOS 6 on a virtual machine and installed Hadoop CDH4 version 1 or MRV1. I also installed R using Yum and Java JDK 1.7.0 version 51. I made sure my user Cloudera was in the sudoers and MapRed group. I set the environment variables in my bash profile to avoid having to set them each time. I did find that Yarn, or CDH4 version 2, is not always supported when you try to integrate Hadoop with other libraries or tools, so it seems safer to assume you need MRV1 at this point. Now that your environment is set up, you can get started by moving the data into Hadoop. Download the zipped Medicare data from the link on the CMS website and unzip it to a directory of your choice. I made a new one called Medicare to store this project. Move the text file to Hadoop. I put mine in a Medicare input directory. As I stated previously, this file is really large. I chose to create a smaller version of this file with just the first 2,000 lines of data to test my map and reduce scripts, and this worked well. Let's take a look at the map R script. It reads the data from the Hadoop file system and loops through each line, creating a key value pair. The state is the key since that's what I want to group by later, and the average Medicare payment amount is the value, which happens to be column 26 in this data set. I create a tab-delimited key value pair. This data set had a lot of other interesting fields in it that you could map by instead. You could also create combinations of values to see more than one piece of data at a time. After the mappings are complete, the reducer shuffles and sorts the mapped values and then combines them to form one key value pair per state. In this case, I want a simple sum of all the average Medicare payment amounts. The output will automatically be sorted into alphabetical order by the key, in this case, state, by the reducer. I ran the Hadoop job on my smaller dataset to test my code first before running it on the full dataset. This was necessary because the actual job took over 7.5 hours on my single node machine with only 4 gigs of RAM. I'm sure this would run faster on Amazon EC2 or a better equipped machine. It was doable though if you want to run these jobs and you have a similar environment. The first time I ran the job, the reducer got stuck after it had processed around 68% of the data. A very helpful person recommended setting the MapRed slow start property to 1 on a forum in the conf file. This forces the reducer to wait until all the mappings are complete, which can be helpful if the reason the reducer is stuck is because the mapper didn't complete. If you have them running at the same time, it's impossible to tell which one is the root cause of the problem. I will also say that watching the counts on the job tracker localhost URL was the only way I could tell at points that there was any progress being made. There were times when over an hour went by and my command line feedback did not change. I could see more bytes being read in the job tracker counts, however, and so I persisted. The job did finally finish, and I peeked at my output in Hadoop. My counts were there, organized by state. This data set apparently includes state codes for military territories, like AA for Armed Forces Americas. These and the NA could be filtered out in the map.r program. I moved the dataset to the local file system so I could work with it in Excel. It's now a very manageable 57-line tab-delimited dataset. Some states have a high total amount of Medicare payments made, but they also have a high population. I thought it might be helpful to normalize the data by population for the state by dividing by population. I found census data from 2012 from census.gov and copied those values into Excel. I used Excel to do the simple division calculation. I saved this data as file.csv after scrubbing it a bit more. The Google GeoChart likes to have the state abbreviations with the US dash appended to the front, so I added those here. Google has a GeoChart API that uses jQuery and JSON to generate an SVG map of the data, and this image is of the data summarized in this project. You can easily see here which states had higher average Medicare payments for their population. Florida wasn't a surprise, but I found South Dakota a bit of a surprise. DC had the highest rate, but this may be because there are a disproportionate amount of hospitals in DC that service a much broader region. Arkansas had the lowest rate of Medicare payments made per population, just below Hawaii. The GeoChart API will allow the data to sit in a file in JSON format, which is convenient for editing or reusing the script with another set of data. I find JSON laborious to write and often make errors. One missing bracket will break the entire map, which is frustrating. So I wrote a Python script to take that CSV file I just generated and turn it into the JSON the GeoChart API is expecting. The script only grabs the first column, US state, and the fourth column, which is the rate I calculated. The GeoChart API will allow you to present more data in the hover text, so you could grab the other two fields. However, you can only map one set of numbers per state for this particular style of map, the region map. There are more options with the marker map. The GeoChart HTML file relies on jQuery, which is freely available from jQuery.com. The GeoChart HTML file also relies on the states.json file I generated with the make.json Python script. For simplicity's sake, I just put them both in the same directory as my geochart.html file, but you could put them elsewhere and update the links. The documentation for the GeoChart is very good, and you will discover that there are many options and you can add to customize the look of your map, as well as labels and level of detail. I could have mapped based on zip code and mapped smaller regions. There's also a markers option where you can create dots that you can zoom in on. I started this project trying to get R Hadoop or Repay to work. I was able to get R Hadoop installed, but was never able to get the sample code to run and eventually had to give up. I worked through several error stacks just to get more and found the user community to be quite small, so had trouble finding the help that I needed. I was also able eventually to install Repay, although apparently not quite the right version. Their download page only allows you to download a version that is apparently a few iterations old, and the sample commands given in the documentation do not work on this older version. I also found out the hard way that Repay does not work with Yarn, only MRV1. I spent a while trying to get it to work with Yarn, only to give up and to try with MRV1. And with MRV1, I was able to get it installed and initialized, but also was never able to successfully run most of the commands that I would need to do this job. I later found the documentation buried in another thread that it does not work with Yarn. So I'm sure with more effort and expertise, these tools work and work well for the people who use them, but they were not well enough documented for me to use them successfully. So in conclusion, with the release of more data from the US government, it sounds like they are aiming to release even more of this type of data. And there's been some releases in the past as well. I think there are more opportunities than ever to find interesting comparisons and insights into healthcare data, and I think that there's going to be more of a demand to do so in the near future, and so I think we would benefit from educating ourselves about healthcare data. And MapReduce does a good job aggregating these data, specifically the integration with R and Hadoop streaming. I think that any of the scripting languages would work well. I chose to work in R because I've been working with some health economists and statisticians, and they seem to prefer R and Stata and some of those other statistics-based scripting languages. I also found the visualization to be easy with an API like Google's GeoChart, and so that's fun to produce results that are easily digestible and look good. So thank you. That concludes my final project on a big data healthcare study.